We will conclude this class by exploring dysfunctions of sleep and dreaming. Part 1 will focus on sleep disturbances and Part 2 on sleep disorders. The term sleep is used as an umbrella term for sleep and dreaming in this final lecture. We studied sleep need and sleep debt in the first quarter of this class, including acute and chronic sleep restriction and sleep deprivation. We had an entire lecture devoted to these because of their frequency and consequences. In part 1 of this lecture, we will begin by exploring a number of other sleep disturbances. Sleep disturbances are generally less severe than sleep disorders, but can still be unpleasant phenomena for which people often seek advice and/or treatment. It is because of circadian rhythm studies that we covered in our sleep need and sleep debt lecture that researchers have been able to study circadian rhythm disturbances like jet lag, daylight savings time, and other shift work. These sleep disturbances are all affected by the circadian clock located in the brain. Do you remember where the master circadian clock is located? That is in the suprachiasmatic nucleus of the hypothalamus, right? Remember that first, the master circadian clock must be reset in order for it to synchronize all of your peripheral clocks. Thus, it takes a while for the master circadian clock to resynchronize all the peripheral clocks that are controlling the rhythm of your body organs. Jet lag occurs when there is a disparity between internal circadian rhythm time and environmental time following rapid, usually airline travel east or west across different time zones. It is caused by conflicting signals coming from the circadian master clock and the environment. The circadian master clock will eventually resync with the environment, but each of the peripheral circadian clocks for various body organs take more time to resync. About 1/3 of people are not much affected by jet lag. For the rest, it can range in severity from mild to strong. Interestingly, morning people, what are they also called in psychology? That would be larks, right? Are more likely to be affected by jet lag than owls or hummingbirds. On average, adaptation at each end takes 1 day for each time zone crossed with westward travel and 1.5 days with eastward travel. But for some people, jet lag can last for weeks. The most common symptoms involve fatigue and sleepiness while awake, yet difficulty getting to sleep after eastward travel and awakening too early after westward travel. Additionally, gastrointestinal problems are frequent because of trying to eat when the body is not biologically prepared for digestion. Although the FDA has not yet approved any medication to treat jet lag, many people have found that using a short-acting sleeping medication can improve their sleep, though they do not improve sleepiness during wakefulness. But remember, the most important note of caution, sleeping pills reduce REM sleep, which is important for cognitive, emotional, and brain health. Most studies show that tolerance and dependence can happen quickly. Thus, these medications should only be used rarely as a last resort and when closely monitored by a doctor. Far safer ways to treat jet lag are: 1. Take melatonin in a timely way, but only to advance your sleep bedtime before traveling east. 2. Optimize your sleep environment. Control light exposure, noise, avoid other zigzaggers, increase your comfort. Drink a lot of water and avoid alcohol and large meals while traveling. Some people in the United States and other parts of the world that have daylight saving times experience a similar phenomenon. With daylight savings time, every spring on a given day, there is a 23-hour night ephemeron called springing forward, requiring you to phase advance. And every fall, there is a 25-hour night ephemeron called falling back, requiring you to phase delay. Because of this, many people suffered jet lag symptoms for a day or so. Interestingly, Monk and Alpin in 1980 found that the effects on mood and perceptions of sleep quality are negative for about a week when going on daylight savings time in the spring, but positive when going off in the fall. In case you're wondering if these symptoms exist only in the mind, note that United States traffic accidents tend to increase 7% the day after springing forward and tend to decrease 7% the day after falling back. There are numerous diverse problems associated with shift work, defined as those who work night shifts or rotating day and night shifts or split shifts. First, there is the obvious fact that shift workers get less and lower quality sleep because they're trying to sleep when their circadian rhythms are programmed to keep them awake. Shift work reduces N2 and REM sleep the most, more so than N3. Insomnia and wake time sleepiness are prominent results. Shift work loosely means working anytime between 7 p.m. and 6 a.m. and or rotating between day and night shifts. Shift workers frequently struggle to stay awake, with about 75% experiencing sleepiness every shift and 20% falling asleep at work. There is lower productivity, more mistakes, and more accidents during the night shift in work environments. Shift workers typically have less job satisfaction, more absenteeism, more negative moods, and more emotional problems, and a 50% higher average number of car accidents. In addition, the social and domestic worlds are diurnally oriented, as are religious, recreational, and entertainment functions, causing shift workers an additional set of social difficulties, including social isolation, more family problems, and divorce rates 57% higher than their non-shift working counterparts. Finally, to add insult to injury, myriad health effects. Shift workers have higher incidence of sleep disorders, stomach and intestinal problems, cardiovascular illnesses, and cancer. They also have higher mortality rates. In our next segment, we will begin exploring parasomnias.